Have you ever wondered how your room slowly warms up when you turn on a heater, or why a fan makes you feel cooler even if the air temperature hasn't changed? These are not random effects. They're examples of convection, one of the ways heat transfers from one place to another. Today, we will be learning about free convection, which happens naturally, and forced convection, which needs a little help from machines. Understanding this will help us see how nature and technology work together to move heat around in our homes, bodies, and the entire planet. Before we explore the types of convection, we first need to understand what convection really is. Convection is the movement of heat through fluids, like air or water, caused by the motion of the fluid itself. When part of a fluid is heated, it becomes lighter or less dense and rises. Meanwhile, the cooler, heavier part of the fluid sinks. This rising and sinking motion sets up a continuous cycle called a convection current. It's this motion that helps heat spread throughout the fluid. You can see this process in a pot of soup heating on the stove. The soup at the bottom warms up and rises, while cooler soup at the top sinks. This keeps the heat moving and the whole pot gradually becomes warmer. Now that we understand how convection works in general, let's look more closely at the two ways it can happen. Sometimes the fluid moves because of natural temperature changes, and sometimes we help it along using machines. These two processes are called free convection and forced convection. Now that we understand how convection works in general, let's take a closer look at the first type, the free convection. Free convection happens naturally, without any help from machines or tools. The movement of the fluid comes only from differences in temperature and density. Here's what happens. When a fluid, like air or water, is heated, it becomes lighter and rises. The cooler parts of the fluid, which are heavier, sinks down. This constant rising and sinking motion creates a cycle that carries heat throughout the fluid. You've probably seen this in real life. When you boil a pot of water, bubbles rise to the surface. That's not just boiling, it's free convection at work. The water at the bottom gets hot first, becomes lighter and rises. The cooler water sinks down to take its place, forming a circular motion that helps us the whole pot heat evenly. Another great example is the breeze at the beach. During the day, land heats up faster than water. The warm air above the land rises and the cooler air above the water moves in to replace it. That gentle breeze, that's free convection in the atmosphere. Even indoors, when a candle burns, you'll feel warm air rising above it. No fan, no machine, just heat making the air move by itself. Free convection might seem simple, but it's powerful. It shapes winds, ocean currents, weather patterns, and even helps transfer heat in building ventilation and natural cooling systems. Engineers study it to improve the design of houses, electronics, and even satellites that move themselves without fans.
We've just learned how free convection works on its own, with fluids moving naturally because of heat. But what if we don't want to wait for nature, or we need faster or more targeted heat transfer? That's when we turn to forced convection. In forced convection, we use external tools like fans, pumps, or blowers to push up the fluid and move heat exactly where we need it. These devices don't just help the fluid move faster, they also let us control the speed, direction, and even temperature more precisely. Take an air conditioner for example. It has a fan that actively blows cool air into your room, cooling the air more quickly than nature could on its own. Or think about your laptop. There's a small fan inside that keeps the components cool so it doesn't overheat. In cars, a pump moves coolant fluid to absorb heat from the engine and carry it away. With forced convection, we're not relying on the environment, we're engineering the flow. That's why this type of convection is used widely in machines, electronics, and industrial systems, where heat must be managed quickly and carefully. Both free and forced convection have the same purpose. They move heat through fluids to make temperatures more even. They both require a fluid like air or water and a temperature difference to get started. In both cases, heat flows from a warmer area to a cooler one. But they're also quite different. Free convection happens naturally when temperature differences cause the fluid to move due to the changing density. It's slower and depends on environmental conditions. In contrast, forced convection uses a machine like a pump or a fan to move the fluid. This means it's faster, more efficient, and can be controlled to do exactly what we want. So, while they both move heat, one depends on nature and the other depends on technology. Now that we've explored both types of convection separately, let's compare them side by side. This will help us clearly see how they're alike and how they differ. I'll start with the cause of motion. In free convection, the fluid moves because of natural temperature differences, no help needed. Warmer areas rise, and cooler ones sink, and that's what causes the flow. On the other hand, forced convection doesn't rely on nature alone. We use external tools like fans or pumps to create and control the fluid flow, moving heat faster and more directly. Next is external help. Free convection needs none, it happens on its own. Forced convection, however, can happen without a machine pushing the fluid along. This extra help allows us to manage the movement more precisely. Because of this, their flow speeds are different. Free convection tends to be slower and depends on a lot on the environment, like how much temperature difference there is. In contrast, forced convection is quicker and more predictable because we control how strong the fan or pump is. Speaking of control, that brings us to the next point, how much influence we have over the flow. In free convection, we have little to no control. It's up to how nature behaves. But in forced convection, we design a system, adjust the speed, and guide the direction of the flow. The control is what makes forced convection so useful in machines and appliances. Let's move to examples. Free convection shows up in boiling water, a hot air balloon rising, or a breeze near the sea. These are examples natural effects of heat. Forced convection examples include the way of a fan cools your laptop or how air conditioning spreads cool air around a room, clearly involving machines to enhance the process. Lastly, let's compare where we find them. Free convection is common in the natural world and its situation where heat simply moves without help. You'll see it in weather, cooking, or even inside your own body. Forced convection, on the other hand, is something we use in technology and industry where precision, speed, and efficiency really matter. So while both processes move heat and involve fluid flow, free convection is nature-driven and forced convection is machine-guided. Each plays a key role in helping us stay warm, stay cool, and stay safe, whether in the wild or inside a smartphone. Convection might seem invisible, but it plays a big role in how we experience the world. It helps cook your food, keeps your home comfortable, cools machines like phone and laptops, and controls the climate through wind and ocean currents. Engineers use it to improve designs, while nature uses it to balance temperature on Earth, whether it's the fan in your laptop or the breeze by the sea. Convection is working all around us. Understanding it helps us appreciate how the world stays in balance and how we can use that knowledge to build better systems.
In conclusion, convection is not just a science concept, it's a natural and engineered process that surrounds us daily. Whether it's warm air rising naturally through free convection or machines pushing air in forced convection, both play critical roles in making life more comfortable, efficient, and sustainable. Free convection reminds us how nature balances heat without any help, like breezes by the sea or warm air drifting upward. Forced convection, on the other hand, shows how we've learned to guide and speed up this process with tools like fans, pumps, and cooling systems. Both types work toward the same goal, spreading heat from hot to cold, but they do it in their own unique ways. Understanding convection helps us design better machines, save energy, and even predict the weather. So, the next time you feel a breeze, stand by a heater, or turn on your fan, take a moment to appreciate the invisible dance of heat and motion that keeps our world in balance.